Use the limit definition to find the derivative of a function with a radical. So for our first example, we're going to find the derivative of the following function using the limit definition. And our function is f of x is equal to the square root of 3x plus 6.
Now, I do want to point out one piece of the directions. It says we want to find the derivative using the limit definition. So if you have taken calculus before, you have learned other ways to find the derivative. However, please don't use those ways. If you know those ways, please don't use those ways to find the derivatives here because the directions explicitly say limit definition. So on the final exam, if it asks this question and you don't use the limit definition, I can only give you 1 point for the correct answer. I can't give you any of the other 9 points because you didn't use limit definition. So just please be aware of that. All right, so we're going to start off. F prime of x is going to be equal to the limit as x approaches, or excuse me, h approaches 0 of f of x plus h minus f of x all over h. And then we can substitute in our values. This is going to be the limit as h approaches 0 of the square root of 3 times x plus h plus 6, and I made that square root sign a little bit too long, minus the square root of 3x plus 6 all over h. All right, so before we do any of our limit solving, I want to take this 3 and I'm going to distribute it into both of those terms. And that's going to give us the limit as h approaches 0 of the square root of 3x plus 3h plus 6 minus the square root of 3x plus 6 all over h. All right, so here we have a limit where we have radicals in the numerator and a function or expression in the denominator. And hopefully remember that in order to evaluate a limit that has radical expressions, we need to multiply both the numerator and denominator by the conjugate of the radical expression. So multiply both the top and bottom by the conjugate of the radical expression, which is the square root of 3x plus 3h plus 6 plus the square root of 3x plus 6. All right, so we can come in here and we can have the limit as h approaches 0. And remember, there's a trick to multiplying conjugates. That trick is we take the first term, the square root of 3x plus 3h plus 6, and we square it. We take the last term, which is the square root of 3x plus 6. We square it, and we always subtract. And then in the denominator, we're just going to leave it as is. Because again, we are going to eventually want to factor out that h so we can cancel it out with a factor of the numerator. All right, so then we can start simplifying. The square root and the squareds will cancel out, leaving us with the limit as h approaches 0 of 3x plus 3h plus 6 minus 3x plus 6 all over h times the square root of 3x plus 3h plus 6 plus the square root of 3x plus 6. All right, then from here we can simplify the numerator by first distributing the negative in. We're just going to give us the limit as h approaches 0 of 3x plus 3h plus 6 minus 3x minus 6 all over x times the square root of 3x plus 3h plus 6 plus the square root of 3x plus 6. Then we can cancel out Like terms, 3x cancels out with the negative 3x. 6 cancels out with the negative 6. We're just going to leave us with the limit as h approaches 0 of 3h over h times the square root of 3x plus 3h plus 6 plus the square root of 3x plus 6. Then we can cancel out the factor of h in the numerator with the factor of h in the denominator, leaving us with the limit as h approaches 0 of 3 over the square root of 3x plus 3h plus 6 plus the square root of 3x plus 6. And then we can take the only calculus step there is in this entire problem and substitute 0 in for h. And that's going to give us 3x plus 3 times 0 plus 6 plus the square root of 3x plus 6. And that's all underneath the 3. Let me just come down here and extend that page. And then we can just keep going. So this is going to become 3 over the square root of 3x plus 6 plus the square root of 3x plus 6, which will finally give us our answer of 3 over 2 times the square root of 3x plus 6. So, woo, we finally did it. All right. So we're going to use this formula in the next question. So when I put up the next question, don't freak out. It's basically like part B. It's a continuation. So this question says, using the definition of derivative, find f prime of 7 given f of x equals the square root of 3x plus 6. So this is actually super simple, because we've actually already found the derivative. So we just have to plug 7 into it. All right, so from the previous slide, we found out that f prime of x is equal to 3 over 2 times the square root of 3x plus 6. And we just want to find f prime of 7. So we'll just do a substitution here to give us 3 over 2 times the square root of 3 times 7 plus 6. Which will end up giving us 3 over 2 radical 27. Which we can simplify down. This is really 3 over 2 times the square root of 9 times the square root of 3, which is equal to 3 over 2 times 3 times radical 3. This 3 and that 3 will cancel out, leaving us with 1 over 2 radical 3 as our solution. All right, I just want to mention, like, what is this number? What is 1 over 2 radical 3 represents? Well, remember, this is the slope of f of x at x equals 7.
All right, folks, that is using the limit definition to find the derivative of a function with a radical.